I'll let some of the guys get in. I was a little late starting the stream, so um, I figured let them get on before I start talking about what I've been working on for last 2 days. I'm only late by what 10 minutes. Let me go grab some stuff while I'm waiting for the rest of the guys to get on. Give me a sec. All right, let me just double check. Uh, Double check the chat, see if we got most of the people on yet. It's kind of funny that I made this chat time slot so that people in Europe could tune in, but it seems like nobody is here. Oh, Francis, hi. So, uh, maybe Francis hasn't been keeping up in the chat, but I'm working on a Haribo Cube. So basically, it's a um, enclosure capable printer. I'm trying to do the whole thing from the grounds up. So I decided to do some rough calculations and some rough sketches last night. And this morning, like I got up really early this morning and started working on it. And I noticed that there's gonna be some issues that I need to work out. And I figured um, also you wanted to use this time slot for the European guys to be able to get on and ask some questions and have some interaction. Um, they figured that give them a chance to get on. 128 idols or September 215, 210. Is that that's PTG? That 215, 205 seems a little low for that. You know, maybe what you should do is you should take like when we meet up, just grab the roll, bring it over, and I could try it out here because I've been printing like here. This is PTG. It's been fine at 240 75. So um, I don't know. Like the other one over there is also printing PTG. So you sure it's PTG? Because they could have given you a PLA roll that says PTG on it. So um, yeah, I would double check that because 210 205 are like to be honest, I can't even extrude a 205 on the of his PTG because it just basically starts clicking a lot. So if it's if you're getting a 210 205, I would think that is PLA actually, because I use not the translucent one, but you seen the yellow ones, and this is done at 240, so minimal straining. So I wonder like 1.2 retraction, fast travel speed. Oh well, I think mine was at 0.9 retraction, and yeah, like my travel was pretty high too. So anyway, so while I will like give a few minutes for the guys to kind of get it on. This is the let me see if I get better so I don't get all this light. This light above me is really killing the contrast here. Let me see. Let's go here. How about this one? So this gray uh, is the Eson PTG, and it came out pretty good. There's some rough spots along the two sides here, and of course now that the cam picks it up, it's a little bit stringing back here because the where the fan is not hitting the back. But this is came out pretty nice. I really didn't have any issues with it, and this is. Yeah, it's Eson stuff from Digimakers. It's like $30 Canadian for a kilo. So actually, was pretty good. I thought like the it's good value for what I got, and it's not this really dark gray versus the other one. This is that light gray. You can tell. Oh, so I guess you really can't tell. Hopefully, see like it's lighter. Come on, focus. Okay, well, you get the idea. The PTG I got from Filaments I see is a noticeably lighter, so that's a darker solid gray. So I guess while I have it zoomed in on me, I will show you guys a few things. So I think I showed this last time. This is the pulley that we're gonna be using for the Haribo Cube. It's a little bit harder to find because basically is a 10 mil bore in the inside, and it's GT2 6 mil belt on the outside. 8 mil rod. You can tell like it's noticeably bigger. Um, So the reason why we are going with the 10 mil rod is uh, the guys that was building the Voron, they found out that 8 millimeter even at the hardened steel rods over 300 millimeters or 350 in that range, it starts to sag in the middle due to the weight of the rod itself, and also the span. This doesn't really allow for 350 greater than 350 millimeter span on the rods. So the the cube, I was figuring out the dimensions. The cube requires almost a 425 mil span across the inside. So yeah, the 8 mil won't work. So we had to go with a 10 mil. Um, and basically the 10 mil on the outside, and then what we do is we're gonna actually use 10 mil on the cross as well. I haven't really worked out that one yet, um, mainly because the inside would be about 350. So we are kind of on the edge of whether or not we use 8 mil. I'd rather use an 8 mil for the inside because it'd be lighter for the travel. So I haven't really worked out that part yet. The other thing is I need to find these 10 mil pulleys, but in a double configuration. I haven't found a double configuration yet. So that means you have to use two back to back. Was something I didn't want to do because one would waste a lot of space. The other one is that the cost, the cost, right? If I get a double, then I don't have to worry about um, buying two of these and then using two. Let's kind of just jump into the back to Fusion. So um, for the the vertical pillars on the cube itself, I decided that we're gonna use an L shape. Um, do we see it better? Yeah. So we're gonna decide to use an L shape um, extrusion. So basically, what that allows us to do is actually have instead of relying on corner cubes, which the cost was high because I think last time I priced it out, the corner cubes that I want to use the that I want to use it was about $6 for the cheap one and $9 for the more expensive one, whereas the entire extrusion was like $16. So it made sense to go this way so that we have more options to what we could do with the extrusions and not really rely on having the corner cubes to for strength. Because the problem with the corner cubes, maybe I'll bring it up and I'll show you guys. Um, should be more prepared. Um, one of you guys know that I really pay attention to things like the twisting of the extrusion itself. So that's one of the problems is that when you don't have a single point. Oh, well, no. So we are talking about these corner cubes last time. I think I showed these last time as well. Um, let's see if I can get this to go. Give this. Oh, that's much better. Okay, so the this was the corner cubes that I was going to show. So let me just kind of zoom in a bit here. Oh, okay. So there's these guys here, and how they work is, of course, now they won't be able to show it. Okay, that's better. So that way here. So what that does is it takes three different extrusions, and you would bolt into it uh, via the middle hole on all three sides. The problem with using this is that you actually need extra reinforcement because if you think about it, the extrusion is going to spin on the bolt and on all three axes. So basically, it won't be truly square. You would need corner brackets on all three corners after you use this to ensure the squareness of the corners. So um, it was something that like I think we needed to solve it, and I just didn't like using that. So with the way this is set up, um, you could, we borrow the same idea that we use for the Haribo 3030 is using the M8 by 40 through one of the holes in the extrusion, and what we do is we overlap one side of it and we bolt through the single hole um, through that way. When we if we zoom out and we look at um, the other side, what we're gonna do on the other side is we have the same setup where we both do the M8 by 40, and this forms a corner. And if once we have 4 of these modules created, we can actually bolt them together to form the top. So I'll show you guys what the top looks like. So I want to kind of draw your attention to let's see, this corner here. You see how this cross member is resting on one section of this, but the same corner, the other cross member is resting on 2. This pattern goes around and it follows the same pattern for the entire cube. So basically, what that allows us to do is, see, there's 2. It sits on 2 sections here, sits on 1 section here, and then basically, if we rotate this, you see that the next section sits on 2, and it repeats that pattern. So each corner is asymmetrical. So it sits on 2 on this side and 1 on this side, and so on. So what the reasoning for that is it allows this one, it shares the 3 precisions with each corner, and each cross member sits on at least 1 corner with 1 and 1 corner with 2 sections. The interface here between this member and this member is going to be square flatness. So once we bolt down these 2, it will ensure that it doesn't rotate on the bolts, because these are butting against each other and will prevent the extrusion from rotating. There's also a we use the same idea as the Haribo 3030. We offset this by 3 millimeters, so we can have a nice extrusion cover for this here. So that 3 mil is carried over from the 3030. Would it be better to use vertical screws in the outside hole of the vertical extrusion and horizontal screws through both horizontal right in the corner? Yes. So sorry, I didn't want you guys to think frozen there for a second. So yes, the like just like the Haribo 3030, there's a lot of faith in that you have to kind of trust the holes being drilled and the countersunk and the cuts being made are square. I mean, if you, I mean that's the premise of anything you build, right? If you build a house and none of your cuts are square and all the holes are off, it doesn't matter, right? It's going to be off, right? So yes, it is relying on the precision of the cuts and on the holes drilling themselves, but it is the is it better than using um, like the how put it? Is it better than using the brackets? Probably, because the brackets um, has a lot of play in it. So the hole through the top is probably going to be more precise than the bracket you're going to use, because the way that the drilling is done on CNC and everything, should be better. I'm a little slow because I'm trying to also process what Rob B is telling me on the chat. I understand that what you're saying is basically stagger these 2 into the inside of the extrusion. So if I was understanding correctly, basically what you're saying is move this corner into this corner here, and basically um, have them both through. But the problem you'll find is that one, the even if you somehow could well, you can send me if I misunderstood you, then um, you can send me the drawing of what you think is gonna work. Um, I don't see how you want to um, where else you would bolt it together. So if you send me a picture of it, that'd be great. Well, while I wait for him to send me that, I guess I'll kind of move on to the build platform. So the build platform I mentioned last time is going to be um, mix 6 plate. So it's a 12-inch by 12-inch by 3/8-inch thick mix plate with 4 holes for the platform holder. So basically, I haven't thought about how to do that yet, but the idea is that there's going to be 4 mounting holes. Each side is going to have some kind of uh, platform that it will the plate will sit on, and then that platform is going to be held in place by M12 rods, and then be actuated by some sort of a stepper motor driven lead screw. That part is sort of the next phase. Basically, the idea now is to kind of get the whole XY movement working on the top first. The simple part is actually the um, the platform itself, because the platform itself doesn't really require that much work. It's just basically going to be up and down movement. So that could come later, and we could figure out where we can actually get both the mechanism later. So let me close this off. So I'll wait like the. I guess I could talk a little bit more about the corners themselves. One of the reasons why I want. I think a bit frame. No, attach your card frame the same way. Oh, okay, I see. So let me just bring it back to where we were before. So what you're saying is basically, if I don't have these 2 bolts here, you say bolt through this side, and then have the 3 precision bolt through to the bottom. Well, then the problem is that you your L extrusion is only held on by 1 bolt. That will spin, like, because there's only 1 bolt that holds it down, right? Um, does that make sense? I mean, if I horizontal bolt here that bolts through here, like if I was able to turn that, you can see that the bolt goes through here. It will block this one. The only free one, like you said, is this one, and then this that it I this is kind of like a bad Tetris puzzle, right? I tried all different combinations of um, if you use a shorter than 40 horizontal latch. Okay, so I guess okay, so I sort of understand what you're saying now. Here's a problem. most places who do the extrusion customization will um, it's going to give you it's going to give you you could do it opposite way at the bottom to lock the vertical piece from rotating. Okay, so you have to remember that, like, I guess I'm skimping over a lot of the limitations of what you could do with the customization on the different manufacturers, right? So one thing is that um, this is what they would have called a counterbore hole vertically, and you are asking for basically a horizontal counterbore hole this way, and then a vertical counterbore hole this way. Um, I have to I have to check whether or not they actually allow the two holes to be so close together. Considering that they like they're within 30 millimeters of each other, so whether or not that structurally is sound to have one vertically here and one horizontal here, and then also the if you look at if I rotate this a little, you see that from the distance between like here and here, geez, is 5.5. So the problem is that like um, I could probably get another 15 in there. So like the if I move this bolt over, I'll probably get another 15 millimeter clearance. So um, I'm thinking that there's not going to be much thread engagement going through this way, and then having the same one go down this way. Because I could go, I like you just don't have room. Like you're just trying to basically stuff everything in here. Is gonna be that 5 mil engagement. Unless we're not like you have this M8 bolt that you're having a 5 mil engagement. Might as well not even bother with that M8 bolt because it's not gonna do anything. It's actually um, for all practical purposes, it's not doing anything. So, if you're gonna be doing that, you better off just removing these two bolts and then going with a horizontal L bracket up here that will give you more strength than a 5 mil engagement on the horizontal bolt. So, um, one of the things, okay, so let's kind of back things up a little and let me explain the reason why this is set up this way as well. Is if you think about it, right? If I was to put any sort of weight, let's say, if we were using if we were using the top as a spool holder or to hold to hold the electronics or whatever, like if we put any sort of weight, that weight is sitting on this vertical member here. That weight gets transferred, right, all the way to the bottom member where I haven't shown the bottom yet, right? But it'll get transferred all the way to the bottom by just the fact for virtue of the fact that it's sitting the um, on top of the extrusion. Now, a lot of if we were using corner cubes or if we were using if we were to kind of hang this off of the end here, then basically all the weight would be on the brackets themselves. So this will actually, I could guarantee you that if you put some kind of board on it and you have the same setup on the bottom of this vertical member, you probably could sit on it and it will be fine. So it's designed to take up a lot of the weight. The other thing is that I sort of had to work within the confines of one of the box. Let me see if I can get a good angle here. You know what? I'm going to go to the other one. Go to the other one. It's going to show a little bit better. Let's go to this one here. So um, okay, so that's a better view. So the idea is that this groove here and this groove here, if you think about it, if you think about and imagine it goes all the way around the whole side, this allows you to put in whatever, like acrylic or MDF into the slot, sort of like a picture frame, so that you would use this slot for the to hold your side walls into the cube, so that you're not bolting it on the outside. You're not trying to make brackets and do all sorts of fancy stuff on it, because that's a lot of what the other guys do is they bolt it onto using T-nuts. They bolt it into the size of the extrusion out here, and it basically sits on the outside. But if we were to put the use this slot and slot it in like a picture frame, then that allows you to also use a rubber gasket to like almost like a window, and actually seal that whole side in. So um, most of the mechanicals is going to be inside that built chamber inside, and then you could seal off the top and bottom by using these the grooves on all sides. Um, the other thing is because I know that stepper motors don't like to be hot, so that this is going to be one of the two corners that's going to have a cutout. I gotta have to figure out how to do this cutout and still be able to run the belt into the enclosure. Is the stepper motor that actually sits outside sits outside the enclosure itself, and what's going to happen is that there's going to be a belt that goes from that pulley, and it drives this one. Um, it drives this pulley, and these two pulleys, if you could tell, there's going to be set screws here that drives this rod. This rod, I haven't drawn out any of the other parts yet, but imagine there's a bearing here, and this whole axle is going to spin by this stepper motor. Okay, and what that is that whole axle, this one, is going to get driven by the stepper motor. That stepper motor is going to provide power to this first pulley here. This first pulley is going to drive this this one and this one. So these two pulleys is going to get driven. And the reason why we need those two pulleys driven at the same time is there's on this rod and on this rod is going to be a carriage or gantry that rides back and forth to provide the Z movement back and forth. And there's going to imagine there's a gantry across this area here, and that those two pulleys will ensure that the two carriages that the gantry is going to ride on is going to move at the same pace. Normally, like you could put another motor on this side and have like two motors drive to two separate carriages, but then you end up risking having synchronization issue with the two motors are running at the same speed, or one running faster than the other, or one whatever. Like you might miss steps. This way is that we have this axle as the reference for both sides and driven off of one pulley. That whole setup is actually going to be duplicated for this particular, or it could be this one, but I chose to use this one. That whole setup is going to be duplicated for this rod for the X movement. So um, the the carriage for the X movement then is going to ride on this axle. So the rods, number one, acts as the axle. Number two is acts as the smooth rod for the opposite axis. So they play two roles in this particular design. Very similar to what pretty much like what Ultimaker and all the other crossbar printers going to do, with the exception that like our motor on the outside, on the outside of the enclosure. The second is the fact that we use M10 for the rods, because we're going this span. This span here is 425 mil across, so we sort of have to use an M10 rod. So if hopefully the crossbars here, the cross smooth rods for the middle is going to be short enough that we could go back with M8 smooth 8mm smooth rods instead of the 10, because the 10 is a little bit heavier. Our other design idea was basically not having a crossbar, but have just the whole gantry riding on these two smooth rods, with just moving it back and forth, and have the motor sit on the gantry itself. That's the other alternative, is to actually have less complexity out, because we don't have this crossbar to possibly jam up the mechanics. Is to have just a gantry, like a regular gantry across the two here, sort of like. I think I think I have a good example. Let me catch up on chat while I try to find the example. Um, yes, it's gonna require a little bit beefier motor. Mainly, okay. So let me kind of talk a little bit about this. So basically, the smaller pancake type motors that you see on our cruisers, they're really smaller than normal. I mean, the normal motors. Let me get one. Like the the normal NEMA 17 size motors are quite a bit bigger than the smaller ones that Prusa's been sending with the kits. So it's not so much that they're beefier because we need more torque and all that. It's just that they're normal, whereas the Prusa ones are just small. Um, the problem with the carbon rods is, I mean, you guys are all freaking out about like um, what they call it, the airborne particles and stuff like that on ABS. Carbon dust is actually worse for you, right? It's not it's not even like uh, biodegradable. So um, the dust from the carbon rods is going to be pretty bad. I wouldn't use those, especially because he's also sanding them down. So normally they come epoxied, or like most of the time it's epoxy. Sometimes it's clear coated. So then they go through and they trap the carbon into the epoxy. But the way um, the way he wants to sand it down to ensure that the bushings move smoothly is probably not something I would do. I mean, I would just leave the epoxy on there and get the correct sized bushing. The AWMP, are those the aluminum ones from my guess? So the best example of what I'm trying to do, I guess, the is going to be cargo container. Um, what they call those? Cranes. That's what it is. There we go. So that is actually a um, pretty good pic. Oh, come on, give me a bigger picture. Uh, Maybe this one. Okay, so that is basically the idea. That's the second idea that we could actually go with, which is having these two would be sort of like the smooth rods that that's driven, and we move the gantry back and forth on the roll, and then on top of the gantry, you would have another motor that moves it side to side. So um, it still keeps the Z stationary. It's just that now we cut down the complexity of the whole design by accepting the fact that we can have a little bit of weight on the gantry itself, and we're not removing 100% of the weight off the gantry. The nice thing about this, you doing it this way versus the crossbar, is that the crossbar, uh, there's a lot of alignment possibilities. When I say possibilities, I mean there's a lot of chances that you mess up. So, with the crossbars, also provide less space for a lot of other things. So, the um, having a sort of like a cargo lift, like cargo container lift sort of idea makes sense, and it's easier to implement. So I haven't really 100% decided how I want to kind of do that yet. So I might have a better picture of this. Or maybe this one. This one's probably a good one. So imagine like this is the two smooth rods we have, and then the gantry moves across. So it allows you to have sort of like a hybrid approach. Yeah. So the problem with the aluminum ones is that um, you could actually see it flex. So I understand that the tensile strength and the you know the 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 behavior of the aluminum is going to bounce back to its original form. But the thing is that you don't care about that. You care about the performance as it's being used. So the aluminum rod. Let me go back to our uh, go back and show you guys first. So let me just kind of finish up with this thought first. So the idea is going to be that we have a carriage on this side, carriage on this side, and a fixed gantry, like maybe another 30-30 or 20-20 that sits on as a bridge across these two rods, and this basically pulls it back and forth like how the cargo container was being moved, and then we have the motor sitting right on that carriage itself, so that we are carrying that load back and forth. But um, for like the simplicity of it, it might still work, and we don't have to worry about having another two carriages and more belts and more motors, because I think that's going to be a little bit iffy. If I do it that way, then I may even go through here and get rid of this pulley here and put like a gear system here for that. Again, like it's not set in stone, but the general idea of a cube is this, and then the idea of using an axle to ensure that both sides move at the same speed. That's going to be the case. It's just how do I drive this axle? That's to be determined, and whether or not having a gantry across these two rods um, is sufficient for what we want to do versus trying to do more complex crossbar like the Ultimaker. Um, Having said that, the um, your entire printer, the whole movement is depending on the um, well, maybe not this one, just these two. Because if you're going to use the gantry, then just these two. Your entire gantry sits on these two bars. So if you imagine, like, if it starts bending, it's going to go like this, and that's where you get the Z banding that sometimes you see in other printers, right? Is it'll eventually work itself out. Like when it gets, it will get it'll dip the worst in the middle because that's where it's the least supported, and then when it gets to the sides, it will be just fine. So you end up with this kind of like a valley effect. So um, I wouldn't ship out on the rods. I mean, they're not being moved anyway. Basically, they're stationary, right? In this design, these rods are stationary. They don't move. so we don't have to worry about the weight. Um, that's why one of the things I wanted to see was, as a upgrade, is to move, if we were to move away from using smooth watts here, because since we don't need it, because we not if we don't do crossbar, we don't need these smooth watts as axles. We can actually go with linear rails here. So we can actually build a linear rail on both sides. So it'll actually mimic exactly like how the cargo containers work. They work on two linear rails basically on tracks. So that will even be a better solution. The only thing I don't like about that is the linear rails cost a lot of money, and we have to do another crossbar here. So what I envision is that we'll go with the smooth wads for the first iteration, and I think as an upgrade or as a modification to that, for if other people want to kind of use their put more money into it or put more resource into it and then do the linear rails, that could be something that we could do afterwards, because that doesn't change the gantry. It changes how the carriages that the gantry rides on, and it's just a matter of bolting it on. So it works out pretty good that way. You don't have to really worry too much about that. And what I was gonna do is actually um, also check to see if there's good linear rails from IGUS for that as well. So the what we were talking about before also was the ability to raise and lower the height of the printer, because basically all of these pulleys and all of these rods is basically gonna interface um, to the top, um, and then you get how they basically work their way down. So you replace the vertical members, and it goes up and down. Like you could raise and lower the Z height depending on how long you buy these vertical members. I think like for the first iteration, if we were to go and stick with like let's say something like 400, I think that's a good number, because like basically you get 300 by 300 by 400 high. That's to cover most of what we want to print. Any bigger than that, you're gonna have to you have to start figuring out whether or not you need horizontal cross members to get better structural integrity, and not a lot of people have the room to fit more than 400 high, because you got to remember it's not just 400 high, right? You need probably another 100 for the mechanism, so and then another 20 on the bottom. So you're probably looking at like 540 by the time you're done. So um, that's half a meter. I mean, half a meter printer is kind of tall. So we could always go, like the reference build is going to be probably 300 by 300 by 300, and then we go to 400 for some of the XL builds. Um, Yeah, I think we covered this last time, was that there's gonna be a heated bed. Basically, what's gonna happen is that this Big Six plate is gonna have silicon heat on the bottom, and you would then apply your favorite build surface. So if that's PI or if that's build tack, whatever it is, you would apply on the build plate itself. Uh, One of the things that, like I mentioned last time, was I want to go talk to the guys to see if there's a way to machine holes into the build plate itself from magnets, so that we could attach a stainless steel sheet on top by magnetism, and then that way you could remove that stainless steel sheet whenever you finish the print, and then put a new one on and continue printing. So that's something I have to look into. But for the first iteration of it, just so that we could sort out the mechanics of the printer. We probably just do like a silicon PDL from the bottom, PI on top, and you have your heated surface. Um, Probably gonna recommend we stick with 24 volt for the silicon heater, instead of like going with a line voltage. Um, the line voltage is going to be a little bit faster, or quite a bit faster actually, but it's a little bit dangerous. I don't want to kind of have a platform that moves up and down with a live wire hanging off of it. So I'd rather have that as a 24 volt silicon heater. DC, so that we don't have to worry about any of that. Yeah, stainless steel or spring steel, whichever is magnetizable, and also something that we could like you said, you could flex so that you pop all the prints off. I think one of the streams I talked about Viltech has the removable build plate idea, right? So we'll show that in a second. Let me just kind of finish up with this with Fusion, so I could kind of stay out of Fusion and not have to keep coming jump back into it. One of the things that I kind of work out is the length of this rod, right? The length of this rod is really determined by the how much real estate I have and how much space I need to leave for the bearing to make sure that this rod serves as the axle, right? The other thing is you notice here is kind of I don't know if you guys see that. You see that there's a rectangular outline. That is basically I could actually take these off. There we go. So they actually indents in the rod itself to ensure that we get a positive bite on the axle, so that when the pulley spins, there's a flat spot for the set screw to get into it. The the problem is that the it it's really tough to figure out where we need this particular land, like this flat spot to land, because the pulleys and the pulley and the motors we haven't really fixed the precisions of that motor to the relation to this pulley yet. So I guess the first thing is we need to make a mount for the motor so that it would fix the precision of this pulley, and then we can figure out where that flat spot needs to be. But it's a catch-22 because if I fix that, I have to make sure I have enough space here to make the bracket to hold the bearing for this to spin. And then if I need to move this out, and then lose the motor, and it's going to be an exercise in just trying to figure out how to make both of them work at the same time. One thing I'm surprised is that there was no questions about tensioning the belt. This belt, the interface between this and this, is going to be a closed loop belt. What that means is that like the normal belts we have to sort of connect the two cut ends together. A closed loop belt is basically like all the regular belts you see in like motors and like like alternators and stuff like that in your car. You would just loop the whole belt around this, and by sliding this motor up and down on the extrusion, we create tension on that belt. So that's how you tension that belt. And if I am lucky enough to find a way to then I can land on a good number for this loop here, it'll be exactly the same in that we would leave enough space on this side to allow the pulley to slide back and forth to tension a closed loop belt that goes this way. The nice thing about the closed loop belts is that you could do that tensioning and not have to worry about the fixing the ends of the belt to the carriage, because it'll basically be a continuous loop. You clamp down once on the carriage, and it'll just move along with the closed loop belt. So hopefully I can find a size that will work for this. If not, then yeah, we're gonna have to, for this particular loop, we're gonna have to use a open end belt, but still gonna have a tensioner on this side so they can pull or push the tensioner to vary the tension of this particular belt for that gantry there. So the I think though, like now that I kind of took the time to visualize and draw out and see where problems areas, there may be problem areas. Um, it's working out well. I mean, I could kind of figure out exactly what needs to get drawn. Like right now, these ones, I need to kind of make sure that this motor and the axle is going to work. So those are probably the first STLs is going to get made is the motor mount on this side and the bearing mount on this side. Then getting the correct axle so that this spins. That's probably going to be the first iteration of it. Then once that happens and I bolt that to a frame, then I'm going to figure out the length of this axle and the tension on this side. Once I do that, then I could then draw the carriages that's going to be on this rod and have the gantry built on top of that. So once at the gantry, I can move it back and forth. Then actually you could plug it in and have it move a gantry forward and back, and that's gonna be the first movement of the printer. Then with the gantry kind of set up across, then work on the motor for the X movement, which I can honestly tell you probably gonna end up reusing some of the Haribo ones because um, having a same vertical design, the double ball vertical for the gantry works. I mean that it's been proven it works. So I'm just gonna have to adapt the carriages at the two ends so that they ride on the smooth rod, and and hopefully we can reuse some of the parts that we already have. So it should work pretty good that way. Um, Once that's the case, then the last thing to work on really is the X carriage, right? For at least for the top movement is the X carriage to mount the E3D and the proximity probe. Once so those three are going to be like the next three major releases of the design, right? Once those three are done, anybody could build the top mechanism and then help to kind of sort out any issues with it. We could start using it for like a simple pen plotter or 2D pen plotter so that you could like draw stuff on paper and stuff like that. We could sort of figure out things like steps per like the pulleys here. What is the steps that we need per revolution to move a certain amount of precision and so on. We could kind of debug that whole mechanism first before we kind of move on to the Z. And then the Z, like I said, is just a matter of making a platform that this build plate sits on and moves up and down the Z plane. So that's the easy part. So that's probably gonna be like the fourth and final for the mechanicals of the printer. Um, and hopefully, what I plan to do is also start to get people involved in like things like how do we get these acrylic or MDF cut, and what do we need to kind of secure them to the grooves for the sides, um, the top, because of what I want to do is for the top is I want to see if there's a way to um, keep the entire mechanism underneath underneath the groove. That way you could put a ceiling to the box. The only problem with that is um, how do you get the filament to get into the extruder? Because the reason why a lot of them are open top is that because the way the gantry moves, the filament is kind of moving in that top ceiling. So um, have to kind of solve that. I mean, what we could do is basically build the false ceiling, like make it higher. Like if we only use 400, make it like 500 tall and have a dead space where the spool could come down horizontally into and kind of make it like a smooth 90 into the extruder. Kind of don't want to do it that way because we have dead airspace. Kind of hard to justify having dead airspace up there. Now, the other thing you could do is, because this thing is going to be built like a tank, we can actually make, like if we go up to like add an extra 200 on top, we could put the spool hold up there. So basically all the filaments inside. But then again, it goes to this problem of heat, right? Because now if you heated this chamber, then all the spools on top is like you're gonna heat up all your filament every single time you use it. So those are the issues that we're gonna have to solve. But for now, like at least for me, for my own use at home, mine is probably not gonna be enclosed on the top. I'm gonna enclose the four sides, three sides, enclose the back three sides, and then have the front open. If I really need to enclose the top, we will figure out some other things to do. But the way I look at it is that it's a very big project. I won't be able to do the whole thing myself anyway, but what I'll do is I'll start kind of like the Haribo 3030 is basically get it started, and then have you guys sort of pick up some of the issues and you can kind of work on those. So that's sort of about as much as I want to kind of show today in Fusion. Um, let's save that and then let's just move this out of the way. Reset this thing. So I'll close this. Oh, this thing. Yeah, so we could do something like that where, but the problem with this is I saw that and it's a lot of work. Is Guess I could kind of make this bigger so you guys can actually see it. It's basically a sliding door, right? That moves along, but it adds a lot of. I feel it adds a lot of weight that the wires has to move those boxes around. So, um, but it's very similar. I mean, the idea is there, right? And um, like even they basically do the same thing, which is having vertical, um, have a vertical setup. I think this is horizontal actually. I can really tell. Yeah, that's horizontal, but I'm gonna go with the vertical so that we could actually reuse the with the Prusa X characters. So yeah, I mean it just seems like it needs a little work, right? Because mainly because the if you look at it, that iris is being pushed around by this bunch of wires. And you're basically using the wire as a mechanism to move these plates, which I don't really like. But the idea is there. I mean, we probably end up could probably print a whole bunch of these plates anyway, and then just get one acrylic made for the top. Um, I guess that's really for the ABS guys, right? Because I think, or that guys who want to use a filtration system to fully enclose the printer. Um, I guess is something that we could try to figure out, but it's I don't think it's a big deal. It's just um, if we could use a Bowden setup, that'd be ideal because with the Bowden setup, you could actually run the tube sideways and then it still feed the filament correctly. So I know a lot of guys don't want to go to Bowden, so I kind of didn't want to push that agenda too much. Okay, so I guess let's go back to here and let's switch to okay. So um, I'll open up for questions, discussions, and like anything that you guys want to talk about because it's been an hour. I've been talking nonstop for an hour, so sort of want to take a break here and see if there's any questions or stuff like that. Just looking at the polling. I'm surprised how well these been. Um, yeah, go ahead. There's a delay, so when you say you have a question, like I usually don't see it until you type it in. So oh, Haribo sticker would be great, and I think you sent me some playing cards last time. Um, so for guys who don't know, I sort of got addicted to Haribo candy. So Skydriver's been buying them from the factory, and he's been sending them to me by the kilos. So, and I've been kind of resending them out to other people. So, um, yeah, that's what we're talking about. I know that thing. I really need to get that going. That's the D bot. It's been sitting here for as long as you guys have seen the stream. It's been sitting here. Um, the that one is missing a motor mount, which I finally got well over a month ago. I got the motor mount for that, and what am I missing for that? Oh yeah, yeah. The I had to talk to Robert Wallace about his 200 by 300 and 300 by 300 build platform because that's what's missing is um, the the heat plate for it. I had to find a good source for the heat plate. So um, that one, the black one you see there is 300 by 300, and let's see if I can get a. That one there is on the bottom there. That's a um, that was a 200 by 300. So there's um, that's two D bots that I had to build that I haven't gotten around to yet. So oh yeah, if as many stickers as you can get, like what I'll do is like whenever I send things out to people, I'll just send them a few stickers and off they go. They could get a few stickers. No, if you send the questions here, it'd be good because like it's the same to me. So Donald, you're going to have somebody build a cube with you to test the design. Um, Once it gets to the point where I feel pretty good in terms of the stability of the project. That's what happened with the original Haribo 3030, right? Is I kind of want to get it to at least the XY moving correctly, and correctly I mean like if I say I want to move 100, it moves that, and it moves it without too many problems. Once I get to that, I think that's a good starting point to have other people involved in building it, so that we have a pretty good idea of any issues we may have with the movement, and also by having somebody else test it also gives me a chance to give me a chance to work on the Z. Um, so it's so it's a good thing. It's a good segue for me to go into working on the Z gantry because that one is probably simple, but yeah, I still have to worry about the clearance issues with the belts and stuff. I have to figure out how to mount the rods correctly so that they don't run into each other and so on. Well, here's the thing, right? So I think the MK42 clone, or even the MK42, right? Because the clone is an exact copy of the from the source, right? So both of those are like what was it, 250 by 210. So I mean, if you're gonna go through all the trouble of building a 300 by 300 um, capable printer, are you gonna stick with a 250 by 210 build plate? Um, you could, because basically the idea is that you're gonna have a rail system, right, where you could build the platform any size you want, and then what's stopping you is basically end stop switches that tells you where home is and so on, right? So and once you do that, once you know what home is, you set the build plate to be the plate you use. So if you want to use MK42 slash clone, you could do that and still get away with it. But like I said, you're just basically leaving a lot of money on the table. You're not using the whole 300 by 300 platform. And the just to give you a comparison, um, MK42 slash clone. I'll just say MK42 for now because the clone is the exact same thing. So the MK42 is 3.2 millimeter PCB. The 3/8 inch build plate that I'm going to be using is 9 millimeter. So it's like 3 times thicker than the PCB. So and also because it's mixed 6 plate, the flatness of it is pretty good. You're not gonna have a lot of issues with it. So I mentioned last stream, I think on Thursday and also again yesterday was um, I'm gonna get somebody to basically perimeter and deck the plate. The perimeter basically means I clean up the cutting edges on all 4 sides, and then decking means ensure the top and bottom surface is within 0.005 inch, which is about 0.12 mil. So 0.12 mil is less than is practically flat, right? So I know some guys would want it perfectly zero or like perfect flat. There's no such thing as perfect flat. It's like 0.005 inch is good enough, and that's usually the model, right? Is if it's not good, it's just good enough. So um, not gonna try to strive for like total zero. So that I hope that explains that. I know that we're gonna be making a 300 by 300 PCB heat bed. Mainly, that's really for guys who are gonna try to build a Haribo XL, right? A Haribo 3030 XL. Meaning, like once that build plate comes, once that PCB 300 by 300 PCB is usable, I will try to expand the build volume of the Haribo 3030 to 300 by 300. Keep in mind though, right, because of the moving bed design, it won't print as well as the Haribo Cube, hopefully, because of the design of it. Um, you basically moving the whole entire print back and forth the entire time that you're printing it. If it's a big print, especially on 300 by 300, it's gonna have artifacts. It's just a matter of the design. It's not. There's really nothing you could do, right? I mean, like you're moving this mass back and forth, right? And it's gonna have momentum. So um, that's one of the things is that that's why you don't see a lot of the bigger printers going that size that uses the moving bed is because of that. Like the kind of there's a diverging school of thought, right? One is okay, we could go Gmax and CL10 and all those guys are going big, but I think the they go big, but they are slow. You try like what I'm envisioning is that we right now we are hitting what 60 to 80 100 millimeter second on the Haribo 3030. We have to be at least that, at least 80, if not 100 120 for this to be worth the effort, right? Because if we're just going to be kind of on par, that's okay. But I thinking that we should be like 120, 140. Like that's what I want to hit is those speeds, and then by having lighter carriages or something like that, we should be able to hit those speeds, and also not have like round the corners and so on. So it's ambitious, but hopefully I think that work out. I don't think that there'd be like it's just a matter of how much time we have and how much we want to settle. If we don't settle for much, then like meaning we don't compromise too much, I think we're in pretty good shape. Um, I I guess I was hoping somebody would ask like time frame. So I could tell you right now that things are busy. I mean, things are crazy. I think I in my yesterday's stream, you guys, if you guys weren't on or if you didn't review it, um, I was I was like either sick or was busy for like 2 weeks, and all of a sudden yesterday, literally I got two 3D hub orders. I'm printing the second Etsy order, but I got like two more to do. Um, I got some local spinner orders like these things. They for my goddaughter, so she's selling them at school, so I gotta make them. I had a few orders um, for these guys, and it was crazy. And then on top of that, the Tindy, I got two Tindy orders to print the Haribo 3030 pot. So like I think I told you guys before, I added it up here. Last time it was about 40 hours of printing for those Haribo 3030 pots. I have to do two of those. So all of that is happening on these two printers right now, and it's taking up a lot of time. But that's a short term. Like in short term, I don't see people putting too much time into it in the short term. Long term wise, um, he said the speed could just be a number which was written down on that day could be lost in quality of the print. I'll get to that Hebo guy later, but let me kind of finish up the thing first. I think I was gonna say there's beginning of May right now, so what I plan to do is have the first movement, or at least the first look, like physical mechanism working by end of the month, and then hopefully a have a working gantry and everything. Probably I would say aim for end of June. So by June, I should be able to allow some of the guys, if they wanted to kind of go on this adventure with me, is basically uh, starting probably the end of June is I will be putting the bomb, um, putting the bomb on GitHub, and then we could see having a few of them built and field tested, and do some test like real world testing on the prints and stuff like that. And then I hopefully by end of July, if all that works well, end of July, I think that gives us 3 months. So May, June, July, give us 3 months to kind of get to a same stage as Haribo 3030 in the beginning, to kind of get to a beta testing stage where we'll start accepting um, built and having prints done. And yeah, I think that's ambitious, but it's doable. I think it's doable. So let's say everything that people sign up for testing by August. I think that's reasonable. So that's basically me working over the summer in the weekends to come up with the STLs. So that's reasonable. So I'll probably start writing this down on the like start a new GitHub repo and start writing this down on the timelines and stuff like that, and then start talking about like writing down some of the issues that we might run into and how we can solve it. We can have some discussions there. Um, to be honest, like what I wasn't very happy with that's his Haribo guy because um, yeah, alpha in late June, beta in late July, um, kind of like opened up for the chat group for a small group testing in August, and then we can see how it goes from there. If it goes well, then I think by September we could kind of do the same thing we did, which is kind of have a wider audience and then let it grow organically. So I'm not gonna go out and actually push it. Like I don't think we didn't do that much on pushing on the Haribo 3030. I know like Jason and like let's say Rob went on Facebook and talked and show off theirs and talked about it a little bit, but it wasn't like we went on Thingiverse and started like pushing it, and like I didn't really talk about too much on stream. So it works well this way because basically, well, we get 2 or 3 new guys every week, and we were able to grow organically and help them and figure out issues, and then if other people will come back and contribute. So I think that's the model we want to go with, is to grow organically, so that we're not having thousands of like people come at the same time and overwhelm us. Um, Going back to the Haribo guy, like I said, I wasn't really happy with some of the stuff he was doing. I know that he wasn't claiming credit for a lot of the work that we have done, but he also was omitting the fact that it was basically Haribo with just longer lead screws and longer longer vertical members. And I guess, in a way, I was sort of disappointed. I mean, I thought the guy would be a little bit more, contribute a little bit more than that. I mean, he, like, even the extruder, I think he just basically took that extruder design off Thingiverse anyway. So there was not a lot of new work done. But then, he just kind of just put it out there and started the Facebook and everything. And then um, frankly, I just don't have the time to deal with him. So I'll leave him with that. If his guys are claiming 120, I think we did 120 into 40 speed test as well. The thing is that it's something that we need to work on, is the acceleration and jerk, acceleration and jerk settings. Because I think what's happening is we are going fast. I think we no, like definitely we are fast. Like how we could do 100, 120. The problem is that a lot of the models are designed with do I have here? Yeah. So a lot of models are designed with um, 90-degree corners. It's just like a car, right? Like you were trying to race around this corner at 120 millimeters a second. Um, the change in direction and change in the acceleration is is causing slight around the corner. I mean, on this one, it's very slight. It's acceptable for things like this where the corners are not really meant for like 100% precision. So it works out. But models like this are not really designed to be printed fast, because whoever designed it didn't really think about this corner, right? So the the problem is that if I print it from this way and then outside I slow down to go around this corner, this strip here is also not fast, like not long enough for me to get up to speed before I have to turn the corner again for the inside, right? So something like this will never um, achieve maximum speed, um, and that's okay, because what we have done, right, is we basically have taken something that, like, we were printing at 40. And if we go up to 80 max speed, but our average speed is about 50, 60, we're still faster than stock. Because at 40 stock, that's max speed. So some of these corners, we're probably doing like 20, 30 around these corners. So that's why, like, you could, if you go slow, you print good on any printer. But it's just that we have shown that we could do pretty good print. I mean, like, this is probably on par with what you get at double the speed. So, that's what we set up to do, and that's what we did. So it's not really, um, I don't really think that I need to kind of verify or um, certify your claims that you did 120. Is if you did something and you told me you did it, it's just built on trust, right? You did it, it's fine. Um, Let me go grab something else to show you guys. So So when you start designing your own parts, what you could do is actually like go with rounded corners, because rounded corners are easy. Like we, um, like the you don't have to really worry about like making a 90-degree turn here. This is a smooth turn. So if you watch your printer print, you can see where it starts to slow down or do this abrupt movement around a 90-degree corner. If you see those, you kind of look at the model and say, hey, when I do the models, I'm not going to do 90-degree corners. That's why there's hex, right? Because hex are easy too. Those are almost a circle. So whipping around a hex hole is also pretty, like, you don't lose a lot of speed, right? So the um, yeah, Rob, like a lot of guys are claiming they do 80 on the stock MK2. Great, I know you could do it, but the thing is that, like, it's just not stable, right? Like I think if you took the print at 80 on a stock NV2 and 80 at on a Haribo 30, you see that the difference is night and day. Like you have no artifacts. You end up you just end up being better. Um, Also, like we could actually dial up. Like that's what I'm saying. We have to kind of work with the acceleration jerk settings. We'll probably dial up the acceleration from the in the firmware because we could go faster. So um, I just never really bothered with it, and I was hoping somebody else would have picked that up. But we're gonna go see from there. The other thing you could do is like if you don't want rounded corners, you could go with 45. So that's why there's 45s here, and it has hex in here, right? It's basically there's 45s in here and over here. 45s 45s are good. I mean, like you just do a slight bend around, like around the part, like just like how you drive. Like you have a smooth transition on the curve instead of like this 90-degree corner, right? So I guess when you design anything, or if you want to design any parts or anything you want to print, you keep those things in mind. Like it makes everything nicer, and also. Um, I think 2 weeks ago I was watching this YouTube thing. It talks about why they don't have square windows on airplanes. Square windows, the 90-degree corner actually has a stress point, so um, they ended up fracturing the window at that square corner. So it's gonna be the same thing if you design any parts that these structural integrity. You need to arc that corner, either 45 hex rounded, whatever it is. If you arc it, you have less stress in that corner. So, that's just something good to do anyway. So overall, I think if we did that, then like when I do the Haribo 3030 parts, they come out pretty good because they all got rounded corners and release and stuff like that. So um, heck, and also like at the end of the day, seriously, at the end of the day is like you guys happy with the printer? If you guys happy with the printer, that's it, right? Like, we don't care if his going 190,000 millimeters a second, right? Is ours go and they print and they work and they have fun, right? So, oh yeah, so I was talking about bearings last time, and I don't know if this probably not going to focus on that. No, it's not going to happen. Um, these are what they call hybrid APEC 9 hybrids. They got ceramic balls, but they plastic races and metal shields. So they still spin pretty good. So I'm gonna put a link on these on the description later. Same thing with these is basically pop the shields off, clean them well, put 2 drops of that speed cream, and these are probably going to be the cheapest ceramic um, you could buy right now. I think these work out to be $3. Don't quote me, but it's $3 each. Like I said, it's the cheapest ceramic you're going to be able to buy. So um, you you should get these if you're going to build any spinners for your friends. $3, money well spent. Um, okay, so basically external MOSFET, whether or not it's going to heat up the bed faster, I guess that's not the primary reason why people use external MOSFETs. Um, we have a lot of heat melting the connector problem. So basically, what the think about the external MOSFET as a relay. You take the trigger on the off the Rambo for the heat bed. Sorry, you take the heat bed output on the Rambo as a trigger for a relay, and then a relay opens the MOSFETs right on the and then allows the power to go through the external MOSFET board instead of through the Rambo. Whether this be faster or slower, that's something that you have to test. But I doubt that's gonna be faster on the Rambo. It might be faster on the RAMs because there's less amperage going through the RAMs. If you go through the MOSFET, you could go full power. So probably he's seen that it heats up faster. Yeah. So the primary reason is that you end up melting the MOSFET on the connectors on the MOSFET board before you melt the MOSFETs on your Rambo. So the TiVo guys and all the other guys are basically using external MOSFET mainly for that purpose, is to as a safety thing against melting the controller. So it's something good to have, but then it's also another point of failure, right? So what I mean by that is um, if your controller has a output for controlling an external MOSFET, it's good. But if it doesn't, then we're basically taking the heat bed power output into an external MOSFET. If the MOSFET fails, it's gonna basically still drive full power into into that output into the MOSFET board, because it doesn't see the increase in the temperature when it's outputting, right? So if I was doing it, I probably won't use it. So if maybe that's what it boils down to, is that it's a hack. And on the Rambo, I'm not sure if it has a line, like I would say, like logic level or line level relay for the relay on the MOSFET board. If it doesn't, and he's basically taking it straight off of, like on the Rambo, taking it straight off of the Rambo heat bed output, not a good idea. We could look more into that if you want to, but maybe that's something that we need more time to cover, and I need more time to look into it. I think that's it. I mean, it's an hour and a half, and I'm getting hungry. I haven't had lunch yet, so um, it's 1:45 in the afternoon. So I think I'm gonna call it here and stop the stream here. I'll see what the feedback is. I mean, if it's not, um, I was hoping like we get more European guys on, but if they're not really coming on at this time slot, um, might just move it back to Thursday. I think it's just easier because you know I lose the morning by doing this. So I hopefully something like they'll start picking it up. Oh, it's what's it, males and single or whatever? Is it May 5th today? No, yes, that was yesterday. I know the Spanish guy would be like May 5th. Let's go drinking, but anyway, I'll see you guys around. Yeah, it was yesterday. See, told you. They're probably still like passed out at the pub or something. I'll see you guys on chat. I'll see in the next. So before I go, the next stream should be Tuesday, I think. Um, Tuesday. What I'm trying to do is do Tuesday, Thursday for incrementals, and then Saturday, if I get enough European guys on Saturday and enough of you guys on Saturday, is I'll do a more in depth dive into the cube on Saturday. I think that works because that gives me Friday night and Saturday morning to work on the design and then do some work, and then by noontime I just have something to share with you guys. So okay, adios.